Good evening, everyone, and welcome to Astronomy for Everyone. Oh, sorry. Welcome to Astronomy at the Beach 2020. Sorry, my name is Liam Finn, and I am going to be do some introduction. There may be some delay in the video, so please bear with us. So we have done some events already tonight. Everybody who's here are members of the Ford Amateur Astronomy Club, and our presentation right now is actually going to be a live views over the skies of Woodhaven by a member of our club called Gordon Hansen. Gordon has been a member of club since the dinosaurs roamed the earth, and Gordon is big into astrophotography. He's into visual observing as well, but astrophotography is a big area. And what Gordon's actually going to do for a slide is actually show you live views of the night sky, and he's going to do live stacking. So he's going to take an image and stack the images live and explain the process to you. And as this happens, you can see the image build out and get more and more detail. And it kind of gives you an idea of what astrophotographers do to extract more detail out of a live feed out of their images when they're actually taking them for their astrophotography. So I'd like to hand things over to Gordon. Gordon, over to you.
Thank you, Liam. Welcome, everyone. I'm going to start sharing the screen here right now. Unfortunately, because of COVID, right now, I'd normally be on the beach with a telescope, and you'd be walking up to me and we'd be looking at the sky live, which is certainly better than any time looking at a picture. But we got to make do with what we can do. So let's give a start here. So we're going to do astrophotography. We're going to do some live stacking. As Liam said, we're going to take a series of turned out 30-second images and start stacking them together so we can build up a little more detail. We're going to go about 20 images on each object, so we'll get about, I think that's about 15 minutes plus some overhead. But that's kind of a rough way to go. And but I'll start with just so you have some feel for what's going on. This is my observatory in my backyard. It's it's a 10-foot dome. It's made by a company called Technical Innovations. They call it a home dome. And through the shutter, you can see my telescope rig. And I'll bring in a little bit closer view of it. I've got a Lasmandi G11 equatorial mount. There's my imaging rig right now. It's a Stellarvue SVQ 100. It's a 100 millimeter refractor. That's the imaging scope. I have a Canon 60 DSLR is what I'm using for imaging. This camera has been modified to allow more hydrogen alpha light in, but that's a detail maybe we can talk about later if there's some questions. We also need to guide the system. So on top of that rig, there's another smaller telescope. It's actually a Williams 66 refractor, and it's got another camera mixed into that. So and again, here's a close-up view of the camera. So there's the Canon 6D, which is typically just a normal consumer grade DSLR, although there has been a modification internally to it, again, to let more of the red light through. And the guide camera is called a Starlight Express Lodestar X2. So that's kind of the technical details, and we don't have to get too much worried about them anymore. Depending on timing and how things go, I'm planning to try and do 5 targets tonight. We're going to start with M15, a Globular Cluster, and then go to M31 Andromeda Galaxy. Then we're going to try the North American Cluster, North American Nebula. Oh, typo on my part there, and the Pelican Nebula, which are right next to each other. Then we'll try M33, another galaxy called in Triangulum, and then M57, the Ring Nebula. That's an ambitious one, but we'll see where we get to. So just maybe a little levity here tonight before we get started. We're going to play a little bit of baseball. Baseball is the national pastime, so we need to keep that in mind as we get to the end of the baseball season. So in the sky, there's something called the Great Square of Pegasus, and so we need a little make-believe here now. So we're going to make believe that this corner here is home plate, and we got first, second, and third. And we've got 2 teams. We got the Pegasus team, and they're out in the field, and the players are Algenib, Markab, and on second, and I always mess up these names. Sedabari playing shortstop, and Sheet playing third base. Out in the outfield, we got Stalula, and then Byham, and then Inif. And we got a pitcher called Salem, and he's kind of moved over the way because at bat is Alfred from the Andromeda team, and he's now just hit a long fly ball that's going out over the fences, and you can see it here, M15. So, and this is a real all-star team out there, but none of them are from Houston. I know, boo. Got to have a little bit of corn, a little bit of smile. So let's get started here.
If we got and we understood baseball, then we might have gotten that joke. Apparently, one of us did.
I didn't know whether to cry or laugh.
Well, what can I tell you? We gotta do some things. So, and in the effort to save a little bit of time tonight, I've already got the telescope pointed at our first target, which was M15 that we just talked about in that baseball game. So we're going to get a little bit closer look up at this target. Let me drag this part onto the screen here. This is my software that's controlling the camera and the telescope. And what we're going to do, I've got this thing set up to take a series of 20, 30-second exposures. For those who are into cameras and want some more details, I'm running this at an ISO 3200, which is a pretty aggressive speed. And part of that is because we're trying to do things in a short amount of time. So I'm going to start taking images. So I'll start to take series, and you can see the timer starting to count as it starts taking an exposure. On this screen here, you'll see what's the guide camera. I've already connected the guide camera and picked out a guide star. And so what the computer is doing is it's looking at the centroid of this star and keeping it in one spot. And you can see the variation as the atmosphere makes it move a little bit. So you can see the variation in the where the telescope is pointing over time down here at the bottom. And this is what we want to see, a nice little ball. I would prefer to see maybe a little bit less running around, but the skies sometimes aren't as perfect as we like. You can see now that it just jumped. What happened is we completed one image, and what I'm also doing is something called dithering. So in between each image, I slightly move things just so we get some better quality out of the images. So that's why this thing shows a spike there. So so that image has gotten taken, and this software, I'm running it inside of an astronomical package called PixInsight, and there's a piece in here called Easy Live Stack. And as each image is completed, that image is then stored off on a directory on the computer. This software looks for a new image falls in there and then immediately grabs it, and you can. It now goes through a process of calibrating the image, then turning it from a raw image into a full color image, and then aligning it with the previous images, and then stacking them together and averaging it. And so that's what we're seeing here now. We have now had a total of 4 images stacked. The 2 I did before we came live, and then 2 more that have just happened. So again, here goes another image just completed. So there she goes again. So like I said, we're taking 30-second exposures and 20 of them. So that's about 15 minutes.
Gordon?
10 minutes, yes.
Can you explain what stacking is?
Okay, what stacking does is we've got relatively short images, and what we do is we take the subsequent images and line them up so all the stars lie on top of one another. Remember I said earlier that we're dithering, so we're actually moving each image around a little bit, a couple of pixels each time. And what this software does is once it's got it calibrated, it takes and realigns them and then it then takes and actually averages the new frame into the ones that were there. So you're getting an average of each of the images. We're now at 6 images, so we've got an average of 6 images. Why this is important is what we're really trying to do, especially on a dim object, is we want to improve the signal to noise ratio of the image. There's some random noise that goes on just because of the nature of light. And by averaging those samples, we can reduce the amount of scatter there is in the image by, getting a little bit of math here, by the square root of the number of images we take. So if we take 2 images, we improve it by the square root of 2 or 1.4 something. We got 4 images, we improve it by 2. We go 9 images and we improve it by 3. We got 16, we improve it by 4, and etc. 20 is at this point for this, what we're doing tonight, that's plenty. We'll see how much, how we're doing and how we're doing for time, if we may even want to cut that short a little bit. But for this one, we're gonna keep it going.
Okay.
So you can see the image is forming in here. I can actually blow this up a little bit and we'll start seeing the cluster.
And that cluster is about 33,000 light years away.
In our backyard, basically, astronomically wise.
So you can see how this, if you look at the background of this image, you can see how it's kind of speckled. That's the noise that's going on in the camera, especially with these high ISO speeds, which tend to be noisy, and a really short exposure. The background can get noisy. So we're going to taking a lot of them. Quite frankly, if I was doing this on my own at night, I'd be taking 60 images or so, not 20, just to drive that noise down as much as we can. You can see the screen on the side that we just did an alignment on the image that was just taken.
For everybody who's actually on the stream, who's watching right now, please, it actually helps us promote the video on YouTube. If you click on the thumbs up and you like the video. Also, since this is the Astronomy For Everyone TV show channel that our club runs, which is the YouTube for that channel. If you click on the subscribe button also below in YouTube, it would actually help promote our channel as well on YouTube. And if you also, it's a good idea, because every time we create a new event, new shows, you will get notified that it's actually either when we go live or if there's a new show published, you'll be notified that the new show has been made available. Thank you. Oh, there was a question. Are you going to ask that question?
What question was I going to ask?
Oh, no, there's a question there asking about a dark frame.
Yes.
Okay.
Okay. When we start the next one, you see me put the frames in here. But when I started this, I had to load in what's called a bias frame, a dark frame, and a flat frame, and that's what's used for calibrating. I don't know if we want to get into too much of the weeds here, but the bias frame is subtracted from all the images. It's a pedestal that's put into the camera so that we don't start dividing by 0, which computers don't like very much. Yes, and then there's a dark frame was a frame taken at 30 seconds, just like these images, but with a lens cap on, so there was no light reading the camera. The point of that is that any thermal noise that builds up in the camera, we duplicate that and try and get that out of the system too, when we're stacking. And then a flat frame, if you had looked at the raw frames here, you would see little black dots all over the place, and that's dust that settles onto the camera chip. When you take daytime photos, you've got so much brightness there that these little dust motes don't show up. But in these dark astro photos, every one of those dark spots shows up as a blemish. And by using something called a flat, we make those go away. And we also even out the image and get rid of any vignetting that occurs.
So some science stuff about this. This is about 100,000 stars in this globular, and globulars are sort of gravitationally bound to orbit the Milky Way, but not actually inside the disk of the Milky Way.
Since we're doing that, let me bring this up while that thing is running, and we'll talk a little bit about M15. As Tim started saying, we're looking at something in the Constellation Pegasus, and that was the team we were playing there, the Pegasus. This cluster is estimated to be 12 billion years old. It's one of the oldest globular clusters in our galaxy. It's, as Tim said, it is 33,000 light years away. So when the light left that cluster to come up to us and get captured by the camera tonight, let's see, 33,000. I guess the dinosaurs were around at that point. My dinosaur history is, despite Liam's comments about how old I was.
I don't know if we had dinosaurs, but I can't think of anything built by humans that would have existed at that time. No,
not 33,000 years ago.
Yeah, no.
And by the way, inside that cluster, there are about 100,000 stars. So let's put this back down again. And how far along are we?
So fun fact about globulars is we used to not know how big our galaxy was. We didn't know where the center of the Milky Way was, and we didn't know how far away we were from that center. And it was globular clusters were used to work that out. Astronomers realized that if they tried to track anything inside the galaxy, we're all going in the same direction. So it was hard to get any meaningful. It's like being a blueberry inside a blueberry pancake. All you see is batter everywhere you look. And everything's going the same way, so you weren't getting any differential movement. But the globulars all have these random orbits in this halo region, and they realized that if they studied them for enough years, they could sort of try and figure out where the center point of the orbit was. Figured out it was in the direction of the Sagittarius constellation. Started pointing telescopes that way, saw absolutely nothing because it was caked with dust. Switched to infrared telescopes so they could see through the dust, and that's when they found all these stars moving very, very quickly around absolutely nothing and discovered the black hole. And then we pinpointed about how far away we were from that. But it's all thanks to starting with these globular clusters.
There's a question there for you, Gordon. And the question is, the question is from Book Davies, and it says, okay, so you can still edit noise after the stack is finished, just showing live picture as exposures are taken.
Well, yes, actually, that's, what we're doing here is a pretty rudimentary stacking process. If I was in a regular astrophoto, when I wasn't pressed for time, I wouldn't be using this kind of software, and I'd be using a lot more sophisticated stacking software that would be doing a lot of pixel rejection and getting rid of a lot of stuff that doesn't belong in the image. In the instance of time, I don't think this image is going to improve much more. So I'm going to abort, and I think from now on we're going to take less than 20 images. The next set we're only going to do 10, and I'm going to stop this here just so that we can keep moving here. So I'm going to tell this thing to stop watching the folder, and then export all the stacks. Okay, so it's going to shut down. So now here's the image I took. And I'm sure you can see that we are loaded with lots of detail here. And that's the nature of astrophotos, especially 30-second images. They don't gather a whole lot of light. So I'm going to do what's called a screen stretch here to bring up what's actually there in the background. So I'm going to make it a little bit brighter, and that brings up a little bit of noise in the bottom. So that's the image we just took. It looks kind of crude. There's lots of noise in the background. It's not the kind of thing you'd want to frame and hang on your wall, but this is only the beginning of the process. So let me bring up PowerPoint here again, and I'm already giving away some of my because now this image that's on the screen, it was exactly what we did tonight. I did a couple of days ago in trying to get prepped for this. So this is same target, 20 images, but this time I ran through a more complete image calibration, stacking process, and processing image to make this thing look a whole lot better than that raw image. So when this image started out, it looked just like this one. So there's a lot of work to be done. And I don't want to scare people off from the hobby because it can be very rewarding, but capturing the image is only step one in this process. So why don't we move on, and we'll try and move on to, I think I said we're going to do Andromeda next, correct? Is that what I said?
I think it was M31, yes.
Yeah. Did
Right.
you, I think briefly you were going to show a finished image? Or you're going to do that later?
Yeah, well, that was it. I just had it.
Okay. All right.
It was in the
Bring it
PowerPoint.
back up again. So this is.
That's it. I was going to ask you the final. So you saw that one, but I thought you had one where you had taken hours worth of data.
I probably got buried. I could find one.
Okay, never mind. Sorry to interrupt. Yeah, there you go.
If it's raining or cloudy tomorrow night, that's what we're going to do. So let's. This will take a few minutes to get here. So what we're going to, let me close some of this down to get it off the screen so you can see what's going on. Did I stop the auto guider? Oh, I got to stop the auto guider. So let me get these off of here just so we can see the screen. So what I'm going to do now is I'm going to go find M31, which is the Andromeda Galaxy. And I'm going to tell this telescope to go slew to it. Make sure I know where it's at. Yeah, okay. So the telescope is now moving. And I'm going to center it on the screen. And just to add some more, when the telescope started slewing, then the software also is now realigning the dome so that the slit on the dome is now in line with the telescope. So you can see it, as it rotated, it's now in the right position. And so we should be able to go in here, and I'm going to take a very short 10-second exposure. So there's Andromeda Galaxy. What I'm going to do now, just to show you what I typically do at the beginning, I'm going to save this image. I always save it to overwrite a file so I don't keep filling the disks up. But then I'm going to do something called a plate solve. So this software is going to look at the picture I just took, and it's going to find, it looks pretty miserable on here, but it's amazing what this software will do. I've already got some characteristics already built into this thing. I'm going to tell it to go tell me exactly where that picture was in the sky. All those green dots are stars. And what it did is it matched all the stars to ones in the picture and said, this is exactly where the camera is pointing. And so it's dead center right on Andromeda. So we're good to go to start doing the next one. So next step here is to, let's get a guide star going. So I'm going to go to the guider, and I'm going to take this is taking a 2-second exposure. And I can go here and just say auto find guide star, and let's see what it picks. that was pretty close to another star. Sometimes that can get you in trouble. So I'm gonna go pick one here manually and take that star, and I'm gonna say start auto guiding. So now it's isolating on that star and it's finding its position, and it's now keeping that star dead center. And you can see there's a little bit of an offset. We'll give it a time for it to kind of settle down and get it where it belongs.
And while we're waiting, guys, don't forget, if you want to ask questions, please feel free to type them in the chat. We will address them as soon as possible. And again, for anyone who's new, who just joined us, click on the thumbs up and like the channel. And we would like you also to subscribe, because we have more events that are going to come out on this channel tomorrow. And if you subscribe, you'll get notified when we go live with our events tomorrow as well. And as well as that, the channel is used by a TV show called Astronomy For Everyone that our club runs, and that records each month. And when there's new shows being made available online, you'll be notified when the new Astronomy For Everyone shows come out as well. So thumbs up, click subscribe and like, and I'll hand it back to Gordon.
Okay. What I'm also doing right now is, since we changed targets, I want the files, the pictures I take stored in a different directory. So I'm picking one called M31. You can see the September 24th was the things I was doing last night to get ready for this, but it'll create a new directory automatically for tonight. So we've now told it where to put the pictures. So the guider is pretty reasonable. It's maybe a bit lumpier than I'd like, but so I'm just going to go and start taking the series. And so again, we're going to start taking, whoop, why is it taking 70? Let me abort this for a second. Somehow this one got, okay. All right, so it's going to be taking 10 example exposures. So now I'm going to bring up that same software, and now you can see there was a question about calibration in dark frames and light frames. So I'm going to tell it we're going to start a new live stack. It's going to ask me where the files are going to be. So they're in M31 under September 25th, and there's none there yet. There it is. So I'm going to take this image. I'm going to tell them it's a color image. And now I'm going to go select, you can see the bias master, what's called the flat master, and the dark master. So I will go get those files and tell them where they are. And they're in a easy stack calibration. There it is. So here's the bias frame. Here's the dark frame. And the flat is in a different directory, but we'll go get that. Okay, and then I'll tell it to start watching the folder. So once again, it's already had a few files there, so it's taking them and starting to run.
We have a comment from Book Davies, and it says, he said, if you could give us multiple thumbs up, he would. This is outstanding. So applause to Gordon for the content.
Oh, thank you. So this is M31, the Andromeda Galaxy. So maybe while this is taking pictures, we can talk a little bit about what M31 is. So let me bring this thing back up, and we did this one. So, there was, I'm sorry, Tim, you're right. I did have a close-up of M15. Forgot it was there.
I had seen it.
You read my mind.
It popped up briefly and then it would disappear. So
yeah, there it is. Okay. So there's M15, a little closer in view, so you can see this globular. Now, let's talk. We didn't really talk what globulars are. Globular clusters are stars that formed out of the gas in the universe, or in the galaxy, especially back 12 billion years ago, where the universe was a lot smaller and denser, and so stars could coalesce out of that gas. With globular clusters, we could form a lot of stars in a very small space. And as a consequence, the gravitational attraction of each of these stars keeps these stars together. They're kind of, think about a beehive with all the bees running around, but afraid to go out in a storm. So they're all stuck together. They will stay together. They've been together for 12 billion years. They're probably going to stay together for a lot longer. A lot of these things are red giants or red dwarf stars, and so their lifetime is measured in trillions of years. They say that any M dwarf star that formed in the universe is still in existence. None of them has gone burned out yet. So that's what's populating this kind of a cluster. So we'll talk about Andromeda. Now we're talking Andromeda Galaxy. It's in the constellation Andromeda. Funny how that works. In this case now, it's 2,540,000 light years away. So the light that we are picking up in the images we're looking at tonight left that galaxy two plus million years ago. It's kind of awe-inspiring when you think about it. The size of the galaxy is in its width is about 220,000 light years. That's about the same as our Milky Way. It has always been contesting on which is bigger, Andromeda or our Milky Way. And every couple of years they change position because somebody discovers something new. But just to give you a feel for how big it is on the sky, everybody I think can envision what the full moon looks like. Matter of fact, if you look out your window right now, we got a first quarter moon, don't we, out there tonight? So we all know what the full moon looks like. This is significantly bigger than a full moon. Andromeda Galaxy is about 6 full moon diameters long and about 2 full moon diameters tall. If you get to some really dark space, go out in the middle of New Mexico desert, or maybe even get up north into the UP, you can just about pull out the core of this galaxy naked eye. Certainly binoculars will do it. But to bring it the outer portions, you're starting to need a telescope. Inside this galaxy is about 1 trillion stars. I'm guessing that's about what we've got in the Milky Way. Anybody got any other?
That number keeps changing as well.
Yeah, the Milky Way is the latest number I heard was 400 billion.
Well, there's a few of them.
Yeah, it's a big number.
Okay, so you're seeing getting a preview. So where we are right now, we got 7 images stacked. Now the 8th one. You can see what's going on the outside. Let me see.
We have the 2 companions as well.
Yes, we've got
M31.
M31. Now I was getting confused. M32. Help me keep.
Yeah. Yes. Correct.
And then M33 is sitting down in here. So just like these are companion galaxies to Andromeda, the Milky Way has Andromeda as companion galaxies. The small and large Magellanic Clouds are the most famous ones. Can't see them from here. You got to go down into south of the equator to find them. But and there's a lot more. So you can see we calibrated them. We debared the image. We're now looking at the star position, and you can see the thing moving by the number of pixels. I know it's going by fast, but so we've got 9. We'll do one more.
You can already see the dust lanes.
Yes. By the way, Milky Way's got dust lanes also, and that's part of the reason. As if you look in the Sagittarius in the summer, it's already set now, but we can't see to the core of our Milky Way because of the density of stars and for dust lanes that are there. So,
which is why we like to use infrared.
right. Okay, I think we're done. Let me make sure over here. This thing's saying still done.
Okay, there's a question here for you, and it's saying, with the EQ live stack works, does the EQ live stack work if you're dithering? And the answer to that is yes.
Yes, yes,
Gordon
we
is
are
dithering
dithering
right now.
Yeah, well, every one of these spikes here were when we ended one image and the software said, okay, I want to move the image 1 pixel or 2 pixels up, down, right, left. And so now it looks at it and says, oops, the star is not in the right spot because the set point moves. And that's why it takes a few seconds for it to now move them out and bring the star back to its new position.
And that helps you with, that dithering does?
Well, we may be able to see it later in M58. None of these sensors are perfect. There's always what are called hot pixels or even dead pixels.
Or pattern noise?
Well, pattern noise also, but the real big thing that gets in here is dead pixels or hot pixels. And if you took all your images and you could perfectly align them as you took them, then those bad spots would just constantly reinforce one another. As you stacked an average, you just keep averaging that hot spot. If you move the images around, okay, and then align the stars, you keep moving the hot spots from one spot to the other. And then with a more sophisticated stacking software, it'll look and say, oh, only this image has a spot here. There's a spot in another image someplace else, but each image only has a spot in one place. So it says, that's a bad spot. Let me get rid of it. So it essentially throws it out. So sometimes you can see some of that in these images. Let me see if I can.
So the computer's able to align the stars, and because the pixels lit by a star in every frame, the computer says it's a real star. But because the noise shifts around, the computer can figure out that that's not a real star. Okay. That's noise.
You see this kind of square array here?
Yeah.
Okay, here's the stars. They're on top of one another because we've stacked them on the line. These were bad pixels. And every time we move the image, they move them to a slightly different spot. So if I go in and stack these in another more sophisticated software, those spots will not be here anymore. They're gone. Let's get rid of this. And so now here's our image again, nice and black.
And Ani says dithering helps with the walking noise.
Yeah, okay. Okay, so there's our image. And pretty much what I just did there is essentially what that software is doing in the fly is what's called a screen stretch. It essentially stretches it so we can see it, but really doesn't alter the image in any way. So now if we come back up here into
and you're shooting these in relatively light polluted suburban skies and without light pollution filters, is that correct?
Yes.
And you're still able to pull that out. Okay.
Yes. Okay, so we had a preview. There's the same images. Now I did 20 images here. This was a stack of 20 done the other night that I went through and did a better processing job. So you can see how much better the background looks. And if I remembered exactly where that group of hot pixels were, yeah, we could go search, and I can't blow this one up from inside PowerPoint. So
yeah, it's important to remember the live stack that you see happening on the screen that Gordon was doing is a quick and dirty,
yes,
basic stacking. It doesn't do all of the advanced stuff that's normally done with astrophotography. So that's why you see it a very hazy, rough image. When you do full detail stacking, these are the type of images that you get you can extract by eliminating all that background haze and noise as part of the processing of the data.
So Gordon, just for perspective, you're grabbing about 10 minutes to 15 minutes worth of data, but when you are not doing this in a hurry for a demonstration and you're just doing this because you want a real solid image for yourself that you can hang on the wall, how much data do you collect then?
Okay. Typically, I will go out a minimum of 4 hours out to 6 and 8 hours of exposures. Now, for those who are interested in astrophotography, there's another club called the Plymouth Astrophotography Club. You can go look up on the groups.io and just look for Plymouth Astrophotography. We meet at the library in Plymouth, Michigan on the first Tuesday of each month. Obviously, we're not doing that now. We're virtual on it also. But we've got people in there, and I don't want to go throwing names out here, so I won't. But we've got a gentleman on there that his minimum exposure is about 30 hours, and he's been up as high as 70 hours on exposures. But he's doing some specialized narrow band imaging where you don't get a whole lot of signal. So yes, you can go nuts with this stuff.
Ani is in your YouTube chat, and he's also in the same group, doing some very nice work.
Let me just to show you where technology has gone over the last century. This is the Edwin Hubble's plate from 1923 that he took of the Andromeda Galaxy.
I thought that was your plate from 1922.
Yeah, well, yeah, only. Okay. This was the image he took in 1923. And you can see up here where you can see these two lines, and unfortunately in this image you really can't see it, but there's a star out here in the middle. He crossed out the N, and I forget what the N was stood for, but he said, no, it's a variable star, and it turned out it was a Cepheid variable. And from based on the data he could take off the Cepheid variable, he then proved that this, what was known as the Andromeda Nebula in 1920, was in fact something outside our galaxy, and was far, far away, and what do we say, 2.4, 2.5 million light years away. So this famous image is one that really brought science a long way back in the 20s. But you can see, by the way, this was a 45-minute exposure taken on glass plate with an emulsion on it. So pair that to what we just did in 15 minutes.
And he did not have a digital autoguider.
That's correct. Yes. If you see pictures of Edwin Hubble sitting at the telescope, what he did there all night is he sat there with a wheel, and he manually took the guide star and he manually moved things around to keep the guide star in the right spot. So for that 45 minutes, he had his eye stuck to that eyepiece. Okay, so how are we doing on time? Well, we can do one more, right?
Oh yeah.
But you don't have a time limit anyway, Gordon. So if you want to run on, you can.
There's nobody after you.
Well, I think what we're going to do next is, I think we said we were going to do the North American Nebula. So we'll try and get some color in here. So let me shrink these down again. I did stop the autoguider, did I not? Yes, I did. Okay. Now, we've been putting numbers in. We've been talking about M31. These are Messier items, and if the weather's bad tomorrow night, my plan is to just talk about Charles Messier and why everything's got his M numbers on it. But this is a sky software, and so we can put in numbers, or we can do things like North American Nebula. And so it'll know things by their common names also. So we'll find it. And okay, now this one is, we're going to transit to the other side. So I got to remind me, I got to do some, when we start guiding, I got to move things around here again.
Just so everybody knows, anyone who's interested in astrophotography and the Plymouth Astrophotography group, I just posted a link to the groups.io in the chat. So if you're interested about joining the group or whatever like that, you can just follow that link and bring it to the groups.io, and you can request to join if you wish to.
Now, Gordon, is it okay if I post your AstroBin link?
Sure.
Okay. I'll go ahead and put that in there. So, oh, Oh, no, I can't do it. You know what I'll do? I'll put it in the Zoom, and then I bet
post
Liam
it.
can do it. Yeah.
Yeah.
So I'll put it here.
Now, Astrobin is a website that that amateurs tend to load our images on, and so you can look at some really great images up there and just browse through the Astrobin site. If
Yeah,
you're
that's the
interested
link
in
to Gordon's Astrobin. I just posted in chat.
If you're also interested in astrophotography, I'd highly recommend that you look at the APOD website. It's a NASA website called APOD, Astronomy Picture of the Day. It's published by, oh, I just lost his name. He's a professor of astronomy at not Northern Michigan. What's the other technical school up in the Northern UP?
Michigan Tech?
Michigan Tech, thank you. And also the other co-editor. Every day there's a new image. Lots of them posted by amateurs. Lots of them are Hubble images. They are phenomenal sets of images to go to look at if you're interested in astrophotography.
And you can subscribe to APOD, so every day when a new one is posted, you'll get notified in your email.
Now, what I like about Astrobin is that most of the people who post to Astrobin will tell you what equipment they use, and they'll also tell you what exposure settings they use. And that means that if you're new and you're trying to figure out how long should your sub exposures be and things like that, you can get a lot of valuable information by looking at good example shots and seeing what other astrophotographers are doing.
Yeah.
So I'm feeling proud of myself because typically when I do something like this and I swing to the other side of the other hemisphere of the sky, I forget to change a setting on the dome, and I take a picture and I get nothing but black. And I start thinking, oh, well, now what broke? But I remembered to make a change tonight. So we should be able to take a little test picture, make sure we're in the right spot.
And this is where I'm guessing your plate solve is going to make a noticeable shift.
Well, since I've been out there in the last couple of days, I'm thinking this is going to be.
Oh, your meridian flips are pretty solid.
Yeah, it should work pretty good.
Yeah.
By the way, the software will do this automatically, but my mount is not a Swiss watch, and as a consequence, I need to give it some time to settle down before I start taking pictures, and the automation won't do it. We're pretty much, well, we're off a little bit. Let's
just want to say, while Gordon is getting set up there, we have some people who've joined. Just to give you information of what's going on. Gordon is actually based in Woodhaven, and he's using his observatory in his backyard to go to an object in the night sky, and he's actually taking images and live stacking, which is basically taking multiple images and adding the data from one image to the next to bring out more and more detail. So we're actually doing this live, and so you get an idea of what's involved. And a live stack is a very rough, rudimentary stacking process, but it will actually show you more detail than you would with a single image. And don't forget, click subscribe and like, and give it a thumbs up to the below, please. It actually helps promote us in the rankings on YouTube, especially the liking and the thumbs up. That actually really helps with promoting.
Okay, the North American Nebula is this here, and it's upside down here, unfortunately, because we turned it up. We flipped from one side of the sky to the other. But I also want to get this in here. This is the North American Nebula. If you kind of turn your head upside down, here's Mexico, here's Florida, here's California. So this is North America, the Gulf of Mexico in here. I guess you call this, I don't know, Hudson Bay up here. That's probably stretching things. But this other one here is called the Pelican Nebula. So I'm I removed this a little bit so we'll get both of these objects into these images.
Now, just for those who don't know, a nebula is a gas cloud in space.
Yeah.
Right? Made up of various gases. And because of its reddish color, it indicates that it's primarily made up of a lot of hydrogen gas.
So we'll get a guide star going here again.
So Gordon, when you have a moment, Ani wants to know, what are you using to capture your subs?
Canon 6D.
Modified? That's
Modified.
a Hutek, by Hutek? Okay.
Okay. Oh, see, I didn't do it. Abort. Abort. See, I told you to remind me. Because we switched the other sky, I gotta do this, and this thing will just run away. All right, so we start over again. Oh, fine, that's not a bad one.
So what Gordon is doing is, for those who weren't here earlier on when he did this, he's picking a star that the guide camera, which is a separate small telescope with a camera on the end, is actually going to use, and to keep the telescope precisely pointing in one direction. So any tiny variation of the movement of that star, the guide camera can detect that and tells the telescope mount to correct its position and keep it in the exact same spot each time, and to follow the object across the night sky.
So Gordon, Ani is saying, no, sorry, he wanted to know what software you're using to capture your subs. He says, it doesn't look like Sequence Generator Pro.
No, I'm using the Sky camera add-in. Okay, I gotta find the, you know what, I'm just gonna, there it is. Couldn't find it. Okay. Okay. So we're taking images again.
Okay.
But now we got to go over here and start this up again. Okay, we have an image yet there? Once again, I got to put in the calibration. Well, I wish this thing would remember.
Sounds like a feature request.
Yeah. Well, you know, I think most of the time, I think actually I had the file master in there, didn't I? Yes, I did. I didn't have to go to another folder. Okay.
Again, guys, feel free to ask questions. We have some gurus on here who are big into astrophotography who'll be more than happy to give you any tips and tricks or any input on astrophotography. If you are interested in that side of things, or you just there to see the pretty images, that's fine too. Okay, we've been asked to showing Jupiter. Jupiter is this whole event is going to be around deep sky objects, really faint objects, not planetary. If you check the glac.org for Astronomy at the Beach 2020, there are probably some people out there who are doing planetary imaging right now, live. But we are concentrating here on deep sky objects that takes, so we're taking multiple photographs and stacking them rather than recording video, which is what you do for a planet.
And the planetary technique is very different. Ani, who's in the chat, I think, Ani, you do a bit of planetary, if I recall, and planets are very bright, and so the exposures are very short, And in fact, they're so short that stars in the background don't really show up. So you would think that there were no stars in the sky, just the planets. And so typically what you do is grab a bit of video. But planets are also very, very tiny. You know, this North American Nebula is, you know, a huge swath of sky, whereas the planet is, you know, a couple of arc minutes, and which means that distortions from our atmosphere greatly affect the clarity of the planet. And so usually what you do is after you've collected a lot of video frames, you actually throw most of them out. The software helps figure out which ones seem to be the best. So it's a completely different process to how you capture the data and how you stack the data than the deep sky, where you take exposures that are many minutes long over hours.
Gordon is doing 20-second subs, I believe. Is that right, Gordon?
30-second subs, and we're only going to do 10 just so we can get a couple more images in here.
Yeah. And as you see, you're a few images in, but you can see some of the red from the hydrogen gas starting to show through.
So while that's building, we can talk about it. As Tim started saying before, North American Nebula and the Pelican Nebula are called what they're called Emission Nebula. They're both H2 areas, and what that is excited hydrogen, hydrogen gas out in that area of the space. The gas is being excited by hot bright stars someplace in the vicinity, which quote unquote ionizes the hydrogen atoms, and as the atoms kind of come back, try to get back to their rest states, they give off different frequencies of light. Hydrogen alpha, or H2, is a very red light. As Tim said, it's fire engine red, and so that's essentially what these objects are made out of. This is pretty close. It's only 2,600 light years from Earth only, but again, it's pretty good size. It's a 2 degrees by 1 2/3 degree on the sky. And by the way, that's just the North American part, not the Pelican side. So it's about the size of 10 times the size of the full moon. So this is, again, another very big object, but they are very, very dim. Even in the darkest skies, naked eye, you are not going to see the North American Nebula. If you got the really dark skies, you might see things with binoculars, but smaller telescopes, especially if you can start putting some nebula filters on, you can start pulling this out.
And Gordon, what is the focal length of the refractor that you're using?
580 millimeters.
500, yeah. So,
it's, and so that's and with the full frame camera of the 6D, that's what allows me to get. We're getting to the end story already. Skunk myself. so we've got 7 done. So.
As you see, you can actually see the shape and so on start to come into play in the image and you can start to see some of the red color starting to show up now. In an image like this, because it's such a faint object, how much hours of data would you collect for this?
Well, I was actually pretty impressed that we got what we got for 30 minutes. My 15-second exposures. When we bring the final image up again, it was pretty impressive. I've taken hours and maybe didn't do a heck of a lot better. So
it does look good.
I'm starting to rethink some things here.
Gordon is a convert to live stacking in the future.
Well, no, I think the live stacking, because its limitations and how it does the stacking, it's a good tool to make sure you're getting what you think you're getting when you're doing the imaging run.
Yeah,
it's not the same as doing a full processing run.
If you were using, say, an 8-inch Schmidt-Cassegrain telescope, that'd be about a 2,000 millimeter focal length. You would just get you'd need a whole lot of images to mosaic together to capture this.
You'd be putting a mosaic together, which is not, which again, this software today will put mosaics together pretty seamlessly with, if anybody who ever tried to do a mosaic in Photoshop in the past, you've got to try and balance the edges, and it can be a real labor intensive process. The tools that are out there today, this stuff happens almost like magic in the background.
There's a question for you, Gordon.
Yep.
Asking, do you still, Ani said, do you still use this camera in summer? He said,
Yes.
I mean, won't the heat affect your images?
Yes. Yes, I still use it. And up until this spring, I'd never really seen a big problem. But I think the camera's starting to get a little bit long in the tooth, so to speak. And I noticed the first really warm day in the spring, my first 4 images really looked good, and the 5th image went to heck in a handbasket. Tonight it's cool enough. It's not doing so bad.
Have you considered building a cold box to put your camera inside?
The 3D printer is already printed the prototype box, and
I've
got the cooling mechanism, and so yes, it's on the drawing boards.
A big thing that's taking place in astronomy is 3D printing, because we can actually design and build our own parts for our telescopes. And Gordon is one of the converts, a recent convert to it, and his. But there's a few of us in the club who are in the Ford Club who've been big into 3D printing for a while, and I'm happy to know that I'm happy to say it's rubbing off on others because you can do a lot. You can be really creative when it comes to making your own some components that you can use for your telescope setup, and to make your life easier rather than having to go out and pay for it and buy it somewhere, which would probably cost about 10 or 15 times the price.
So I just thought I'd mention that. I'm holding, if you can see it, this is an example of a dedicated astro imaging camera, but this one happens to have a cooling system on it. So there's a Peltier cooling system, there's a fan here, a cooling system, and these things are able to drop the temperature of your chip down to about 40 degrees Celsius below whatever the ambient temperature is. Now, one of the problems with these are expense. So I would say probably a cheap camera that has if it has a cooling system, a cheap version probably starts at around $500 or $600, and they go up into the thousands of dollars from there.
Maybe to answer part of Ani's question, tonight the ambient air temperature is just under 15 degrees centigrade, so it's on the chilly side.
Yeah, and
the camera, by the way, because of heat generated internally from the pictures, you can see it's up at 21 degrees. So we get about a 7 or 8 degree temperature rise because of the electronics in the camera. The cooling box, I'm building my test down in the basement on the workbench, and it was 70 degrees or 68 degrees in the basement. I got the camera down to about 35 degrees Fahrenheit in about 20 minutes using a prototype cooling box. So.
And just since we were talking about 3D printing,
okay,
I'm up in the corner, but here is my part I created for my telescope. It's a container for my my Pi, because I use a Pi to control my telescope, and I made it so it's sprung mounted, so there's no screws, no tightening anything. You just slide it on over the dovetail, and then take your Pi.
Okay, this is our stack of 10 images. And let me just, because so we don't have to turn our heads upside down, let me turn it 180 degrees so we get it right side up.
Nice image.
And so here's a North American nebula, and I think when it's right side up, it's a little more apparent. Gulf of Mexico, Florida Panhandle, whatever. I can't find the Great Lakes in here. Pelican Nebula is over here, and if you look here, one of our club members, George Carodi, he pointed this out. This is a weasel right here. So that's the weasel. Let me bring up the ones that I processed. Show it up a little bit better. So there's again the same using 20 images, and then doing a more normal processing. We get to this, And so you can see the weasel sticking out. You know, here's his two eyes and his snout sticking here. So
There's a question for you, Gordon, asking, have you considered a cooled OSC like the ASI 294 or the ASI 071?
yeah, I'm always considering the next best thing.
He accepts donations.
It's one thing to consider, it's another to buy it.
You know, I've got myself suckered into a full frame camera just because, got it, bigger is better. A lot of people have heard me say this. When I went from my previous camera, which is a relatively small chip, to this full frame, it caused all kinds of grief because I had to replace just about everything on my optical train that handled a bigger chip. So whether would I ever do it again? Well, I've already done it.
Yeah, you would.
But if I knew then what I know now, I would have stopped and done an APS-C side, which is a slightly 24 by 18 chip rather than the 36 by 24. But I've already got it, and so any camera I get, I think it still wants to be a full frame camera.
Now, I will just make a comment because Book made a comment earlier about wanting to do planetary imaging. If you want to do planetary imaging, really big sensors typically can't handle a very fast frame rate.
That's right.
And you need a fast frame rate. So typically, cameras that are good for planetary work have really tiny sensors, like the size of the pinky fingernail. And so it's a completely different kind of camera that you'd want to get if that's what you wanted to do.
Okay, so what did I say we were going to do next? I think we're going to try and do M57, right? Oh, we're going to do the triangle.
Yeah, the ring, correct.
So we don't have a time limit, so I'll keep going as long as we've got an audience and people want to see more. So
I'm actually, with such a short amount of time, I'm amazed how much you pulled out of the North American.
yeah, so is I.
Yeah.
That's what I'm thinking.
Don't forget you to stop tracking. Or stop guiding, sorry, not tracking.
So we're gonna do M33 now, right? So we gotta.
Oh.
You know, we did a globular, we've done a galaxy. You know, I should have thought we should look around and find an open cluster. What open cluster is open up there?
I'm trying to think of some. There's a few nice ones around Cassiopeia.
Oh, there's loads of.
Okay, so now I'm going back to the other side of the sky here.
What about the double cluster? You've got a big chip. You'll easily get the double cluster on that, right?
Maybe we ought to do that first, and then we'll just. Okay, we had to slew that side anyway, I think. So maybe we'll just go to that would be good.
And you get two open clusters for the price of one.
Yeah.
Now, if you had a great big Schmidt-Cassegrain telescope, it would be a tight squeeze to try and get
Okay.
both clusters, both halves of the double cluster into the same frame at the same time.
That's the right one. So slew to that now instead.
Oh, there's a question from Pranav, and he said an arc minute is 1/160th of a degree, correct?
An arc minute is 1/60th of a degree.
1/60th.
Yeah, that's what he has.
And an arc second is 1/60th of an arc minute. So an arc second is 1/3600th of a degree.
Yeah.
Oh, it looks like it's going to fit in there pretty nice.
Oh yeah.
So let's make sure we're there. Oh, see, did I change the, no, I didn't change the
Shutter compensation?
yeah, it's in the wrong spot. It's got to spin around. Actually, it wasn't that far off. It probably would have worked. Whoop, what did I do? So now I'll take the image.
Oh, Pranav says, I don't understand what you mean when you are explaining how to capture planets, Tim. I think that's directed at you.
Yeah, so boy, I don't know if I have any. I could grab my planetary camera and show what it looks like. Ani was capturing the sun earlier today.
Yeah.
The obvious difference between the sun and a planet is that the sun is huge. So it's roughly a half a degree in the sky, or 30 arc minutes, whereas planets are usually much smaller. But regardless, they're all bright. And so you're capturing very, very fast frames. Obviously the sun is brighter, but you're shooting through a heavily filtered telescope. You're not shooting through a filtered telescope when you hit the planets. But what you want to do, so let's just say you wanted to take an image of, say, Mars. You might capture, say, 30 seconds worth of video frames. Whereas if what Gordon's doing is capturing, 15, 20 second deep sky exposure is just one of them, and then he's grabbing, lots of them. Now, if he were doing this out in a darker sky location and trying to get hours and hours worth of data, he might be taking exposures that are many minutes long per exposure. But this is more of a demonstration, and you wouldn't want to wait hours before you started to see things come up on the screen. But with planets, really just 30 seconds, maybe a minute. But the atmosphere is distorting the quality of what you get. And so most of those frames are not going to look great. You're kind of looking for nights that have better seeing. If the stars are twinkling hard, that usually means that the atmosphere is doing a lot of rippling, heat and cold mixing together, distorting your optics. And so you're going to have a higher percentage of bad frames. But what you want to do is capture, and you'll end up with thousands of frames. And then the computer software goes through and analyzes and tries to figure out which frames seem to be sharper, have better contrast, and it will reject the lower quality ones. And then you use planetary stacking software versus what Gordon's doing, which is deep sky stacking software. Deep sky stacking software is using the positions of the stars to align each frame neatly on top of all the other frames. Planetary image software doesn't have any stars to align because the images aren't long enough to get stars to show up. So it's using the disk of the planet to line it up, and it's looking for contrasty features on the disk of that planet. And so maybe you only keep 5 or 10% of the frames that you shot, and you throw out the other 90, 95% to try and bring that image together. So how you capture for planetary is very different than how you capture for deep sky. The type of camera you use is very different. Because planets are so tiny, probably a telescope with a very high focal length is better than a short focal length refractor. So the equipment's very different. So, when we do the live events, people, what's the best telescope? There is no best telescope. It's what's best for the purpose that you're trying to achieve.
The one thing I would add for those interested in planetary, 10 years ago, those of us doing planetary then were using webcams, $39. Now, the cameras out today cost a little bit more money. They're not terribly expensive, and they do a whole lot better job. But we did planetary work doing Jupiter, Saturn, Mars, using a $40 webcam. They did a decent job. The other nice thing about it is that the software for doing the stacking, so to speak, is free. There's one called Registack, and the other one is called Auto Stacker. Both of those are available online. They're free. Just download and start using. I'm sure there's a place on there if you want. They would be glad to take a donation from you. But and they're phenomenal pieces of software. I think what most people are doing today is using they'll grab their video stream using, help me with this, the capture software, Fire Capture, and there's another one. Fire Capture isn't free though. Fire Capture costs a nominal fee for that one, isn't there?
It seems like every time I get a camera, they give me free software with it, and a lot of times it will be, for example, Fire Capture. But I'm on a Mac, so I completely different software. I'd have to ask Ani what he uses.
Ani uses Fire Capture for the solar.
Yeah.
He was using it today.
Like I said, though, the auto stacker is typically used to do the stacking, and then the next level of processing called wavelet processing is usually done in Registack. So one does one thing better than the other, and then you can just kind of transfer the stuff from one thing to the other. Okay.
Ani just said Fire Capture is free, Sharp Cap is free up to a limit. But yeah, it is up to the limited, and then you have Sharp Cap Pro, which you pay for a fee at a yearly basis subscription to have all the pro features. Actually, anyone who does any imaging using our astrophotography using a Pi, Fire Capture comes free. You can actually install it on Raspbian for free to use it on if you want to use a Raspberry Pi on your telescope, like I do. I use a Pi on my telescope, but you can. Fire Capture is free to be installed on a Raspberry Pi.
And now the downside from an equipment standpoint is, I'm using a 588 millimeter telescope, which is essentially a telephoto. I mean, that's what all telescopes are.
Yeah.
But to do Jupiter, Mars, Saturn, you typically want to be up around 3,500 to 4,000 millimeters. So you're talking, typically what happens is a Schmidt-Cassegrain or other 2,000 millimeter focal length, and then putting some kind of a Barlow or I've just lost the name, but Telview calls their multipliers. But anyway, you get away with a little bit less expensive camera, but your telescope tends to be on the more expensive side.
It was a PowerMate.
PowerMate, there we go. Thank you. PowerMate's the better way to go, but you're paying for Teleview's quality or name.
Yeah.
So you can see this starting to go. We've got two open clusters here. Okay. They are not next to each other in space. It's only from our perspective that they appear close together. I don't know if I can get in here and what if we can start doing some lookup and see what the distances are. The difference between a globular cluster we saw before, the M15, and these open clusters is, again, we've got stars that are forming out of a cloud of gas that coalesces and starts forming stars. But now there is insufficient gas in that cloud, so to speak, that the number of stars that formed is nowhere near as great as the globulars were. And so there is, the stars form together, but there's insufficient gravity to keep them together forever. So over time, they start to drift apart. So you go to a starbirth region, and if you've seen things like the Orion Nebula or something like that, is where new stars are being born. The stars get born there, and then they tend to, like I said, start to spread out through the sky. If you recognize the Pleiades, the Seven Sisters, that's an open cluster that's relatively young. Those stars are still pretty much being held together, as are this double cluster. But if you look at another cluster, probably the Beehive is probably less. It's a bit older, and the stars are starting to move apart. And then you wouldn't think much about it, but if you, and I can't remember which ones, I think it's the Handle stars in the Big Dipper. The Handle stars in the Big Dipper are moving in a pretty much a unified things, and the theory is that those were all formed together in the same cluster, so that but now they have enough time has passed that they're really getting spread out. The Earth was thought to be formed in a similar type thing, but our sister stars, it's been so many years, 5 billion years since the sun formed, that our sister stars are spread someplace in the Milky Way galaxy and very hard to pin down where they are. So
I was just going to mention that the N star of the Handle and the opposite end of the Big Dipper, the N star of the Bull, are not members of the cluster, the open cluster, but all the other stars in the Big Dipper are.
Okay.
And a few extras. There's something like 55 stars in all that are part of the, it's called the Ursa Major Moving Group. So on the question about the planetary versus the deep sky, so this is a full frame, in my right hand here is a full frame deep sky imaging camera. This camera, because it's full frame, you pay quite a premium and it's cooled. So expect to pay north of $3,000. I think I got this on sale. This one was about $3,600. But the chip is massive. This camera here, on the other hand, is not cooled. It doesn't need to be. This is a planetary camera, and you can see how much tinier the chip is in here. And these things, maybe $150 would be an entry-level one. This one is probably about $350. You could maybe go up to about $400 or $500, maybe at the top end limit for a planetary camera, but it's generally not necessary. Usually $150 to $300 is pretty good.
Has anybody looked outside? Because I'm looking at this image and I think these are cloud bands. So I wouldn't.
Yeah, it looks like it's getting hazy out there. I haven't been out, but let me check my my sky camera.
Yeah, right.
It's clear over here where I am.
Well, I'm just seeing something in there. So
yeah,
oh,
I'm seeing that. I'm seeing those streaks as well. I'm not sure what's causing them. I don't know if they're clouds, but I'm seeing a little bit. But I've been seeing those most of the evening on my all sky.
Yeah, you can see this stuff, and I think that maybe cloud. Now, unfortunately, I haven't done this one before, so I don't have an A to B comparison of process versus unprocessed. But what I can do is, here's an image I did of the double cluster earlier in the year, and so this was probably done. I'm sure that I've got a couple of. Well, since these were star clusters, I tend to do less on these. I'm guessing here this was like 3 to 4 hours worth of images. I'd have to go back in my archives and see what was there. So that's a fully processed one compared to the one here. Whoop, I lost it here. Let me bring it back up. So I don't know, for
darker background.
Seconds for 3 minutes. That's not all that shoddy, quite frankly. Well, do we want to try triangulum, or we got anybody else got a request?
I thought we were going to try the ring.
You want to try the ring? All right.
The ring is a beautiful image, and it doesn't take a lot of data either.
Yeah. Okay. But all right, I did practice that one last night, so that was on my list. So let's.
This is like a TV show. Here's one I made earlier.
All right, let me shut this one down. We'll go to the Ring Nebula. I think any of us who do imaging or visual, we've got favorites that we go to over and over again. And the Ring Nebula is one of my top 5 image things to look at. I appreciate it even more through a telescope visually than I do from imaging. And there I don't see any color, but it tends to be high in the sky in summer, and sitting out there when the sky gets dark and just kind of watching the skies get darken and the stars start to pop out, you can see Vega pretty quickly, and you know that the ring is pretty close. And getting a telescope on it and watch it start to materialize and show up, and that's one of my favorite things to do.
Mine is M13. I like the ring, but M13 is probably my number one.
Yeah.
It's a globular cluster.
Okay, where are we? Okay, we're going to be on the other side. Well, we're going to be right near. Well, let's see what happens here. This is. This is getting close to transit time. For those who aren't familiar with German equatorials, you got to flip them 180 degrees when something goes from the east side of the meridian or the north-south line to the west side. And we are pretty close to the meridian now. What is transit on this thing? Transit is at 10:06. So we should be well past it. Oh, all right. We're good to go. We were on the other side already.
And there's been a request by Ani from, if there's time, for M45, the Pleiades.
Okay, M45 is, I imaged that the other night, and it's really not up till about 2:30, 3 o'clock in the morning.
Yeah, it's pretty low right now. It is up, but it is low.
I don't even think it's. I don't think it's up yet.
No, it is already up, but I think it's low on the horizon, I believe.
Yeah, well, okay.
It's currently 20 degrees above the eastern horizon.
Yeah.
And I see Taurus and the Hyades are right on the horizon.
You know, if I had trust, I wouldn't do this, but I don't have trust. Yeah, it got there pretty good, so we're good to go. Now, you realize we're only at 580 millimeters. So
yes, it'll be tiny.
Yeah, so
We should get really good color saturation.
yeah, well, okay. Photo guider, photo. And where are we, by the way? Did we cross the meridian? We are positive, yes. So we are on the west side. So
Ani is asking, can you automate your imaging sessions with the SkyX?
I had been using CCD Autopilot, and so like Sequence Generator, I've looked at Sequence Generator Pro, but when I was shopping, Sequence Generator Pro would not work with the Sky. I hear that maybe it does now, but I was using CCD Autopilot, but it's been giving me some issues with guiding. I think because of communication from through multiple pieces of software, there was too many delays, and the guiding really wasn't as good as I'd like it. So I've stopped doing it. I've been now just staying up and watching. Well, I go to take naps in the process, but
yeah, Tim Campbell and I and one or two other members of the club use Raspberry Pis for our automation of our imaging. You can actually program the sequence, multiple objects throughout the night, and it will go from one object to the next and then plate solve and take your images and sequences based on what you programmed.
CCD autopilot will do that, and will
Yep.
also stop, and you tell it, if I want to refocus every 60 minutes, it will stop, go find a focus star, refocus, and come back, reacquire the target, and start up again.
Yep.
It'll handle the meridian flips, and but it was giving me some fits, and it was
The Pi will do
I
actually.
had to put in wasn't. I decided I'm just gonna do it the old-fashioned way, and but
The Pi will do all of that as well, though.
Yeah.
It will do all of the refocusing. You can set how often. You can it will even close your dome for you if you have an automated dome. If it sees the scene dropping below a certain amount, or if it knows there's bad weather coming in. So, they're all doing the same thing. They all have similar features. It's just one has got processing power to do more than just run a sequence, with like the Pi does, whereas this can actually do the live stacking and so on, whereas you can't do it on a Pi. Not really, well, you can, but it's not as efficient. It takes longer because the processing and memory power is so much lower.
I'm going to bump this out to 15 just to get a few more in here, because this is a pretty tiny object, and I think we need as much help as we can get. Okay, we get the first one yet? Boy, I sure wish it would remember this stuff. All right, where is it? There it is. Okay. Till it gets the second image, the software waits. So even though the one was there, it doesn't do anything with it until the second one shows up.
Well, there's
It
nothing to
does
stack.
averaging, isn't it?
Yeah, okay. And I've seen this before. Sometimes it waits for the third one to get in there before it'll start, because there should be two in the folder now. Yeah, there's two there. So what's gonna? Oh, why isn't it going? Well,
Murphy's playing his game.
yeah, I'm gonna bomb out of it. Oops, make sure. Now sometimes, let's start it up again.
Okay, Brooke Davies has said, if planetary imaging doesn't pan out for me, I'm really thinking about spectroscopy. That's a whole different world. Actually, tomorrow night, speaking of spectroscopy, there is a presentation. Tim Campbell and myself will be talking about, but primarily Tim, about spectroscopy. What time is that? 8:30 tomorrow evening? Is that correct, Tim?
I think it's 8:30 to 9:30 Eastern time.
Yeah, 8:30.
Okay.
So
I will actually very briefly just bring up the spectroscopy software so you'll see what it looks like.
Oh, it's running now, Gordon. Yeah.
Yeah, if you, this particular part of the suite doesn't give you the warning, but the other pieces in this easy processing suite, which has only been out here for about 5 or 6 weeks. This is new stuff. When you start it up, it says this software is under heavy development. Be careful when you use it. We take no guarantee that it's going to work.
So you're SOL basically if it doesn't work.
Although I had some issues with things in the beginning, and I got in contact with the developer, and very responsive. And again, this is free.
The best price, isn't it?
Yeah.
But you get what you pay for.
Okay. We said something is tiny. There it is.
Yep, it's tiny.
You might have to click the plus button once or twice.
Yeah, I'm going to
Or
bring it.
10 times maybe. Oh, the color's starting to show in though. Nice. And you can see the white dwarf in the center also.
Now, let's see if I can move this thing. There we go.
So this object is an example of what we believe will happen to our own star when it
That's right.
dies.
Someone in about 5 or 6 billion years time, someone will be looking at our galaxy in our direction and say, oh, look at that planetary nebula.
See, once again, you see this stack of spots here?
Yeah, it's dithering.
And my guess is as soon as the next one comes in, there's going to be another one show up there.
Yeah, that's a set of green ones, and there's a set of red ones farther down below it.
Yeah.
Now, because of the number of frames you're getting, it's attempting to average them out. If you have enough data, it can do some statistical analysis that does a much better job of getting them out.
Oh yeah, that's what I was saying before. If you
Yeah.
do the normal processing, there is pixel rejection routines that, we just had a problem.
Yeah.
Oh, I see red messages.
Yeah, okay. What this means here, I gotta shut down PixInsight and I gotta restart it. So I gotta do the old, because I've been here before.
That's the Microsoft way. If at first you don't succeed, reboot.
If rebooting doesn't fix it, reinstall. If reinstall doesn't fix it, reformat.
Then just go buy a Mac.
Okay, so let's try this one more time. 3 times a charm, right?
That's what they say.
It's a nice heart nebula there you got on the background. Where'd you buy that?
I'm sorry?
I said, that's a nice heart nebula you have on your screen desktop background. Where'd you buy that?
Oh, it was about 6 hours of image processing, and probably about 6 more hours of processing. And
Ani has said, Gordon, I think you're getting more and more dead pixels. I think it's time to buy a new camera.
well, you need to talk to my accountant.
Yeah. You know, I recently bought a bicycle, and on the counter at the bike shop, they had a sign that said, for a small fee, we will provide you with a receipt that matches what you told your wife you spent.
That wasn't one of your corner bicycle stores, I suspect, knowing what's going on.
Yeah.
Now it's got lots of data to work on, so.
Yeah, it's going to crank through.
Zoom in on the nebula, you can see it building out as it gets processed.
You know, last time I did this thing, crashed.
Oh, okay.
but we're going to do it because we're looking at. By the way, for those who, let me bring this down to full size. For those of us who would like to go out and find the M57, if you, oh, we crashed again.
Oh.
Well, I don't know what's going on here.
Well, go ahead and finish your story about locating it.
Okay, if you find Vega in the sky, which especially in summer months is right overhead, part of the summer triangle. It's part of the constellation Lyra, and there's there's 4 stars that are that kind of form the body of the Lyra, and the bottom set there's 2 stars, and that's those 2 stars, and the Ring Nebula is almost perfectly on a line between them, about 1/3 of the way across. So that's the quick way to find them.
It's easy to find in a Dob or most telescopes. It's really easy to find.
Okay, I don't know what this is not. I'm almost, if I was by myself, I'd be rebooting the computer right now.
Well, we're an hour and 40 minutes into the show, so it's up to you if you want to keep going or what. We were initially planned for an hour, but we are continuing because people are on and they're asking good questions. They want to be involved. They want to see what's going on. So,
well, I've been down this road a couple of times. When this thing starts doing like this, it's and just rebooting the software. I suspect that easy thing is doing some things with memory, and it's probably got a memory leak or something, and it's getting over my head here quick.
Yeah.
But
so you want to call it, or?
Well, we can do some other things. If somebody wants to just see images, I can bring some images up, or
let's ask everybody, guys. What would you like Gordon to do? Would you like to say good night, or would you like Gordon to bring up some images that he's done of stuff he's done in the past and discuss the image and how long it took to get there and the work that he's done?
I'd like to ask Gordon to show us the favorite image he's ever produced.
Oh, that's a good question.
Oh, wow. Well, okay.
And for those who are in chat, the response that we got, well, if you need to, let's reset for tomorrow event. But, and Arnie's keep saying, bring up M45. So it's too low right now, Arnie. It's really low.
All right, Gordon.
It needs to be higher.
So Gordon, you stay up until 3 in the morning.
Well, I did that last night. Actually, I did image M45 last night.
Oh,
I haven't even looked at the subs yet because I was getting ready to do this today. So,
so let's look at your favorite image, which is the first ask.
Yeah, I'm in the wrong. I'm looking.
And then we can look at last night's image of 45 to keep Arnie happy.
Okay, wait a second. This has got to be in among my favorites.
Oh, yes.
So this is M42, the Orion Nebula. If those kind of new to this game, if you go out on a summer evening and look to the south, excuse me, if you go out there and look right now, I'm getting myself confused.
Late at night it'll be up. It's a morning object right now.
Yeah, you gotta wait. Well, we're already about midnight. Ryan's probably coming up, isn't it? Let's see where we're.
It'll be rising soon, but it won't be overhead till around 3 in the morning.
Taurus is coming up, but not yet quite Orion.
Yeah.
So Gordon, this was like a week and a half or so after you picked up astrophotography is when you got this image?
Yeah, this was, you can see January 2019. So this one probably has, I'd have to go back in and I didn't start keeping really good records until, probably late last year. So I'd have to do some scrambling, but I'm guessing it's probably at least 8 hours in this. And it was also taking with.
You took this with your iPhone, right?
Yeah.
He drew it by hand.
If you look at the constellation Orion and you have the 3 belt stars, and I think just about everybody who's ever looked up in the sky has noticed the three belt stars of Orion. If you go from those 3 belt stars and go down towards the legs, you'll see what looks like a star at first glance, and in fact, what is there is the Orion Nebula, which is actually technically this part here, and that is a star forming region. It's a birthplace of stars, and what's happening is down in the core is what's called the trapezium, and these are really hot young stars, and you can see them all in here. Now these stars are big, bright, and their lifetime is relatively short. So these are going to glow and burn out in probably millions of years, versus the billions of years that our sun is going and the trillions of years that an M dwarf will run. But to do this image, I had to go down to about, I think I shot 2-second exposures at ISO 100 to get anything down here that wasn't overexposed. And then I had, my guess is I'd have to go back and look, probably out in the 15-minute region of exposures to pick up this faint nebulosity on the outside. So to get all of these together took some, not only stacking of the individual groups of images, but I had to do something called high dynamic range stacking. For those doing even daytime, there's what's called HDR, where you can take images at multiple exposures or f-stops, whatever, and then blend them together so what is overexposed in one is properly exposed in the other, and what's then underexposed in one becomes properly exposed. So you get the best of all the worlds by taking multiple images and putting them together and let the computers blend it. So that's what was required to do this one.
I'll just briefly share my, where'd it go? There we go. Is this it? I think this is it. There we go. If you can all see that. I'll just briefly share that there's where Gordon was trying to, there's Orion. Now this is at 4 a.m. tonight. So it's, there's M45. That's what Ani's been asking to see way up there at the top. But these are those 3 belt stars, and then there's it looks like a star to your naked eye, and but if you were even to grab a pair of binoculars, you'd notice that it doesn't quite focus like a star. And that's because it's a nebula that's so bright that you can actually see it with just your eyeballs.
Oh, there's a Pleiades.
Yeah, that's M45. So this is a couple of years ago. This is 2013. So, problem with this is all the stars are burned out in the core. So we'll see what I did last night when I get around to processing.
We're waiting. So tomorrow at Ani's solar imaging that he's going to be doing tomorrow afternoon, because he got to see M45, he's going to do a dance for everyone at the beginning of his event.
So now Ani has a new request, Gordon, which is, what is your the first image when you were new to astrophotography, the first time you took an image that you thought was a decent image?
You should charge him for all these asks. You make money out of him.
Okay, I don't
know.
know.
Ani Gordon's like a drug dealer. Only the first taste is free. Now you gotta pay.
Okay. right, what we got to do here then is we got to go down through this list and find things with dates back to. I mean, we got a bunch of 12s. We got to get back to 2006 and 7. And I don't know if anything's here. I don't know if I even want to show any of those. 2009, I think, was my first trip to the Winter Star Party.
So wouldn't these images be on floppy diskettes, or were they still on 9-track tapes?
Yeah. Here's 2008. So that's M17, right? That's a Swan Nebula, and then M17, right? Do I get the numbers right? Not too bad, I don't think. How come I'm not hearing anybody?
No, it does look good. Looks really nice.
So that's 2008.
Yeah.
Gordon, have you used the same mount for your telescopes all these years?
I got the Los Mandy, the G11 in 2005, and that's when I started doing imaging. So soon after that.
And then you had to get a PhD to work the software? Was that what happened?
Well, back then there was practically nothing. I mean, we were using Photoshop is where everything really happened, and the stacking software was, oh God, it's been a few over the years. I'm not sure if I can even remember all of them. I can remember in the beginning trying to do stacking in Photoshop, which was a trip. Because then you had to manually move you brought all the frames into different layers, and then you move each layer around so the stars lined up. And then you set the opacity of each layer. The one layer was at 100%, the next layer was at 50, and then the third one at 33, and ad nauseum down to you really couldn't get much more than about 10 frames in before you're.
And I think you mentioned it. While it is the same mount, you've upgraded the system on it. You mentioned that when you first got that G11, it was not a go-to telescope. It was motorized, but you had to manually point it.
Yes, it was a push to, and I had digital setting circles on it from Argo Navis, and it worked very, very well. Once you got a model built, you put in you pick the object, and you started moving the telescope until the counter went to 0. And just like we were doing tonight, the object was pretty much on the chip at that point using the Argo Navis system. So it worked very effectively. But I would never go back.
I use a Sky Commander. I don't use it anymore. I used to use the Sky Commander, which is similar to the Argo Navis on my Dob.
Mm-hmm.
And Ani wants to know, Gordon, when did you first start astrophotography?
Right, like I said, I bought the mount in about 2005, and it was probably soon after that. First images I took were with a Minolta SRT 101 with film and manually guided. And
so it was after the era of the daguerreotypes?
Yeah. I figured I could do this on the cheap because astrophotography's got to be easy, right? And we want favorites. I'm looking up on my wall here. So we need NGC 7293. Let me find that in here.
Well, I'm guessing the Heart is probably one of your favorites since it's your desktop.
Well, yeah, that's been up there a while. I may be putting. I just did the Veil Nebula. I may be putting that up there just because. What did I say? So there it is. Okay.
Oh wow.
Now some would say I cheated on this one, because this is probably about an hour period.
Is this from telescope time from somewhere else?
Yes, this was taken from Siding Springs, Australia, outside of Melbourne, using their T30.
Look how
Probably was a plane wave, either 17 or 24 inch. I'd have to go back and look again.
right.
And you can tell it was a cool CCD camera. You can see the blooming going on in the stars. So this was a very, very sensitive CCD camera. It was on that rig. I've seen people do pretty credible helix from up here in Michigan. It doesn't get very high in the sky here, so it's a tough one. But in Australia, it was right overhead. So
It's cool when you're looking at like something 2D and it almost feels 3D.
yeah. Again, this is another planetary nebula with a white dwarf in the center. We saw the heart. Yeah, well,
Did you say that you finally you imaged all of the M objects now?
yes.
Is that recently completed or is it been a
Well,
while?
it's never completed because now
Well,
what my plan was for tomorrow night, because the forecast is clouds, is to go talk about Charles Messier and the Messier list and what kinds are in there. Now, whether I don't think I want to try and go through all 109 images, but I thought I'd work my way through some of them. But I have done all of them at least once.
okay.
But some of them were done 10 years ago, and they need to be redone.
Skills have changed.
So this is my helix, my Veil Nebula from just recently. This
Oh
is
wow.
August of this year. And this was a combination of single shot, again, using a Canon 6D just as an RGB, but then I also used the Optolong L-Enhance filter for another series of images and then brought them together. That Optolong L-Enhance filter is absolutely wonderful.
I've heard that. I was wondering because you weren't using filters tonight, and how often do you normally use filters, and when do you decide to use the filter?
Well, something like the Veil is essentially all emissions nebula. So it really, what the Optolong, what the L-Enhance filter does is I call it a quasi-narrowband. It only allows the light from the hydrogen alpha region. I think I guess it at about a 20 nanometer wide bandpass for hydrogen alpha. And then another 20 nanometer pass that picks up oxygen 3 and hydrogen beta, which is down in that blue teal region.
Like 3 filters in one, or is it 4?
Yeah, it's one filter that it's a notch filter, so to speak. So it only allows light through in those two bands.
Oh.
A lot of the light pollution filters, that's what they do, is they block the light from the sodium vapor lamps but they're becoming less and less effective as everybody is now switched over to LED streetlights. Because the LED streetlights are a continuum. They're not discrete light sources anymore. So the good news is the amount of light that's being reflected into the sky is going down because these LEDs tend to be full cutoff lamps. But the bad news is that they're full spectrum, so light pollution filters don't work. But for something like the Veil or for I would probably be good. I may even go back and do Orion Nebula again using the L-Enhance filter because it does a really great job.
So
There's still a lot more nebulosity out here in the center of this that I couldn't pull out of the skies here. My guess is if we got down to Lake Hudson or some up the Great Lakes Stargaze up in that I'd pull in more stuff into the center portion of this.
So Gordon, Ani said you're welcome to join him at his HA solar observing session tomorrow, and to ask him all the hard questions. So it's approaching, or it's just turned midnight, guys. I think it's a good time to wrap it up because it's been a 2-hour session. It's been a phenomenal 2-hour session. Gordon, you've done amazing things with quick live stacks.
Nobody is more surprised than me about this.
Well, that's a good thing, right?
You got the gospel according to, was it Garp? Wasn't that, what was it? How did that go? This has rocked my foundation of what works.
Well,
now the problem with this is that I went out and took a whole bunch of veils. I only went down. I went down to 3 minutes instead of 8 minutes. But I still got 60 of these things. You know how long it takes to process these things?
Yep. That's why you do it. You love it. Come on, admit it.
Yeah.
Well, I think everyone got a good idea about what is possible with some short exposure live stacking. And Gordon, thank you. Let's hope and pray for tomorrow night that it's going to be clear skies. We doubt it, but if not, still come back to us, because we're going to go over Gordon's going to do, if the weather is overcast and doesn't work well for doing this type of event, Gordon's going to do a walk through some of these Messier objects that he's taking images of over time.
Yeah, but we'll also talk about Charles Messier and who was he? Who was this dude?
Okay.
Why do all these images have his name attached to them? But don't give anything away, because you probably know.
I'll say nothing. That's all Gordon's for tomorrow night. So thank you all. I hope you learned something. I hope you enjoyed it. Please share the links to your friends once the video is published out there, so we get more people to read and review and enjoy what you've experienced tonight. And hopefully, remember tomorrow, Great Lakes Stargaze. You put Great Lakes Stargaze in my hand.
Yeah, I know.
Great Lakes Association of Astronomy Clubs, GLAC, Astronomy at the Beach 2020 is actually again on tomorrow. Starts with solar observing, both white light and hydrogen alpha are starting at around 3 o'clock in the afternoon. I'll be jumping into some of the solar stuff to cheer on some of the scope owners that are showing some of the solar stuff, and maybe Tim Campbell will join some of them as well, I imagine. And then we'll go back into tomorrow evening show where we have our keynote speakers. We also have other events going on. We have a great spectroscopy event tomorrow evening at 8:30 with Mr. Tim Campbell, and I'll be on that with him also. So please check the schedule on glac.org, and I hope to see you all tomorrow evening. And thank you for joining us tonight.
Fun.
And yes, the time is 3 p.m. EST. All of the times for GLAC events are EST because we're in Michigan. Thank you, and have a good evening.
Good night, all.
Good night.
And with that, I will stop the live stream now.